Okay, so Mylena and Janessa, here we go. So let's do the ellipse first. So the ellipse we're going to write in two parametric equations. What is the x-coordinate of the center of that ellipse? What? 6. So I'm going to go x equals 6 plus, I'm going to say plus 5 because from the center to the edge is 1, 2, 3, 4, 5. So 6 plus 5, x always gets cosine t. Thanks. Spaced out there for a second. Okay, what's the, because from the center of the ellipse to the side is 5 units. We're going to do that now with the y's. Side to side is the x, up and down is the y's. Okay? All right, so for this one, what is the y-coordinate of the center? 9 plus, how far up or down does it go from there? Just the 1. Sine t. And of course, you don't need the 1 there. I wrote it to emphasize the fact that it's 1 unit from the, because the y-coordinate of this point is 9. So the 6 is right there, the 9 is right there. All right, then the tricky part, which Taylor and I discovered yesterday, I was thinking that this was going to be the challenging part. The tricky part is coming up with the equations for the lines. So do you want to do the line on the left or the right first? I think we did the right one first. So in order to come up with an equation for a line, you need two things. You need the slope and you need the y-intercept. The slope is easy to get because if I start here, where's the next? We went 2 over 1, huh? But it's not really. Yeah, it's not. I mean, you're fine because we went through it together, but if you look at it up here on the big screen, like up 2 over 1 and then up 2 over 1, see how it's like getting worse and worse? So the next place that this line actually crosses is way up there. So the slope of that is up 1, 2, 3, 4, 5, 6, 7, 8 over 1, 2, 3, 4, 5. So very close. I don't know, but like I said, don't worry about it because that's my fault because I was looking at the book with you. I just didn't see it very well. Okay, so the question is, how do you figure out what the y-intercept is? If you know the slope is 8 over 5x. Extend it down. Yeah, that's kind of awkward though. I mean, I don't have room. You guys don't have room. You'd have to draw in the book. Is there an algebra way that we can do that? You don't, okay, the way the algebra, how you find the y-intercept. And this is a little bit different than what you and I did yesterday. So, because I need to know the equation for this line, and so to come up with that equation, I need to know the slope and I need to know the y-intercept. Where it crosses the y-axis, okay? Gus, I don't really care. I don't want you to be talking about anything right now. Okay, so I start with y equals mx plus b. Kai, bring it up here. The way that I'm going to find the y-intercept is I need a point on that line. So I can either use this point at the bottom or I can use this point at the upper right. Any preference? Bottom? Okay, so the coordinate of this point on the bottom is 5, 1. Okay, do you agree? You shouldn't agree because it's wrong. Thank you. It's 6, 1. Yeah, I made a mistake there. Okay, so the coordinate of that point is 6, 1. No, I totally just screwed that up. Okay, I'm distracted. I'm trying to do math. I'm also trying to keep Gus focused and trying to keep Kai focused, and got a lot going on up there right now. Okay. Okay, so then the way that we find the y-intercept is you take the y-coordinate of this point right here, which is 1, and you plug that in for y, right? You take the slope, which is 8/5, and plug that in for m. You take the x-coordinate of that point, which is 6, and plug that in for x, and then you solve that for b. Okay? And this is gross because that weird fraction. I liked it much better when we thought it was up 2 over 1. Yeah, this is going to be, yeah. So 1 equals, sure, what's 8/5 as a decimal? It sure would be. Okay, good, thank you. So 1.6 times 6 is going to be 9.6. So if you subtract 9.6 from both sides, you'll find that the y-intercept is negative 8.6. Okay? And then we have to restrict that from x equals what to what? Because this is only this line right here. 6 to 11. So 6 is less than or equal to x, less than or equal to 11. You mean, okay, so do you understand I got the 9.6? Okay, then I just subtracted 9.6 from both sides. So 1 minus 9.6 is negative 8.6. Say it like again. Right, so then the slope of this one is the same as this but opposite. So it's y equals negative 8 over 5x. But then, okay, hang on just a sec, Sky. Why is this negative 8.6? Because 1 minus 9.6 is negative 8.6. Right here, you mean? Down here? Oh, okay. I see what you're, yeah, I understand your question. Because this here is on the left, but then when I write the final answer, it's back on the right again. Okay. Because when I get this answer, I'm just figuring out what B is. And then once I figure that out, then I'm just plugging it straight into that. Whether it's positive or negative, it just stays the same. Yeah. Sky? Okay. All right, so then we have to do the same thing again to find the y-intercept of this one. So y equals negative, well, you guys said you wanted to go decimal, right? So let's go y equals negative 1.6 x plus b. What do you want to plug in for x and y? Let's go 6 and 1 again, yeah, because this point is on both of those lines. So if I plug in 1 here, and then I plug in, this time, positive 6 here, then that's going to be 1 equals negative 9.6 this time plus b. So if I add 9.6, I'm going to get b equals 10.6. And this is from x equals what to what? 1 to 6, because this is the piece on the left. Okay, so these are your 4 equations. Okay. Did we? Because the slope is not negative 1/2 or whatever. But then when you look at, yeah, okay. All right, so let's take a look at number. Yes. I mean, B is doing it on the calculator to check your work. We're going to assume that we got it right, unless you guys really want to do that. Okay, that's fine. No lunch today? No touch. Okay. Okay. I did much in touch, yeah. I'll shoot my shot in wrestling and I'll have some touch. In math and basketball, not so much. Erica, you good? Okay. I got it. Okay, let's try this again with number 8, and hopefully it'll get slightly easier, okay? What is the equation for the x thingy for the ellipse? Okay, the x coordinate of this point is 13. It's 13 comma 6, so we're going to go 13 plus 1. So you don't really have to write the 1 there, but I'm going to just for educational purposes because it's over 1. Yeah. Okay, what is the y coordinate of that point? Love it. Y equals 6 sine, or y equals 6 plus 4 sine t. Because from the center to the edge, it's 1, 2, 3, 4. Okay? 1 to the left and 1 to the right, yeah. Well, because Vanessa's distracting you. Yeah, these are slightly different. Yeah, you were doing the ones where you were taking the equation and then solving them and showing that it, you know. So I'm sure you still understand that. All right, let's come up with the equation for this line right here. No, this line right here. You're top student, Mylena. 3, 6, and 13, 10. Okay. So what's the slope in between those 2 points to start with? How far up do you go to get from 6 to 10? 4. How far over do you go to get from 3 to 13? 10. So that we actually can reduce. Or would you guys like to go decimals? Decimals? Okay. So let's make that 0.4. And then let's figure out what the y-intercept is. Okay? So which point on that graph do you want to use? 3, 6. So 6 equals 0.4 times 3 plus b. So b, hello, we're doing some math up here. Please pay better attention. Thanks. So if 6 equals 0.4 times 3 plus b, then b equals what? 4.8. So 0.4x plus 4.8. And again, we're going to restrict this from, well, 0.4 times 3 is, okay. And then we're going to restrict this 3 less than or equal to x less than or equal to 13. Okay? What? Oh, I was just okay. Right. So this is the same slope but opposite. We can put in the same point because that's on both of them. So this is going to be 6 equals negative 0.4 times 3 plus b. So this time when we multiply those together, Sky, it will be negative 1.2. So we'll add 1.2. Yep. So that'll give us 7.2. And that is also from 3 to 13. The little braces. You have to take like an entire college class to become a teacher where you practice. No, just kidding. Oh, nice. They're dedicated. Thank you. Yeah, all your skills.
Yeah, it's so horrible to be basketball.
We did not do that, Vanessa.
King Crispy did. What? When I have pork chop, we go,
Well, time must have been running out or something.
no, we just wanted to do it.
That never happened. No. No. No, it was not. No, it wasn't. All right, number 10. Shh. Oh, thanks. I was looking at that number right there. Okay, so got an ellipse here. What did you say, Taylor? So the one on the, you're going to do this one here. I don't like the one though. It's like a half. Okay. 1 plus 0.5 cosine t. Oh, you went 14. Student? Mm-hmm. Okay, so these two things, yeah, x and y, that's going to be for this ellipse over here. Okay? This x and y is going to be for this ellipse right here. And then this y and y are going to be for those two lines. So there's 4 pieces. This is 1 part of the graph. This is 2. That's 3. And that's 4. Okay? I tried to turn that in. It's supposed to be a 14. And I accidentally wrote a 1. Okay. Taylor? Plus 0.5 cosine t. Taylor? 4 plus 2 sine t. Uh-huh. Alrighty. Okay. Okay, and then these equations for these lines are really easy because they are horizontal. So what's the y value of the top line? 6. And so it's y equals 6, and we're going to restrict that from x equals 1 to 14. And then what's the y coordinate of the line on the bottom? 2. And we're going to also restrict that from 1 to 14. And if we were to graph that, we would get this nice three-dimensional, as you pointed out yesterday, looking diagram. Yeah, that is way easier because the lines were horizontal. All right, and now we're on to number 10, the last one. This is going to be easy also, Sky, because the lines are vertical, so the equations will be really simple. I'm going to set up an x and a y for, right? So this is for one of the ellipses. This is for another one of the ellipses. This is for one of the sides of the cylinder, and this will be for the other side. Okay? Yep, so this time the x coordinate is the same. Right. Okay. Kai, you gotta do a little better. Okay, you want to do the top one or the bottom one? Top one? All right, so you went 7 plus 6 cosine t, and then you went 8 plus, what'd you do? Okay. Yeah. No. I was just going to make it like 1.2 or something because it's a little bit past 1, but then yeah. Okay, what's the bottom one? Again, 7 plus 6 cosine t. And the y is, awesome, 2 plus 1 sine t. Okay, then for the lines on the side, since they're vertical lines, they're x equals instead of y equals. So what is the x coordinate of all the points on this line? 1. So that would be x equals 1, and then we would need to restrict that where y goes from 2 to 8. Right? And then the one on the other side is x equals 13, and that also goes from y equals 2 to 8. Okay? Yeah, they're way easier when the, right. It's a good little algebra review though. And then we will begin reviewing tomorrow for the chapter test, which will be sometime next week. I would like to spend some time going through some problems and then also give you a practice test. So I want to spend a couple days on review. So probably like Wednesday next week. Okay? Yeah. In the circle. Wouldn't that be fun? I'll see if I can throw that together. Yeah. That would be for tomorrow. What does this mean? Oh, okay. Okay. I didn't know what was happening there. No to Taylor. Is that like, Cody, is that just like international sign language? Like if I'm in Italy and I see someone and they go like this, it's like, oh, no to Taylor. Is that how that? All right, let me yak at you a little bit. Mylena and Janessa, your seating situation is in jeopardy. Let's just say you got a yellow card already. This says you have learned that an inverse trigonometric relation, such as the arcsine of point 4, has many values. But when you enter the inverse sine of point 4 into your calculator, it gives you only one of those values. And so we've talked about this a little bit before. The reason for that is they have to take the inverse thingies and restrict them so that the thing is a function, it's continuous, they want it to be sort of around the origin, centrally located, and then if you have two choices, they like to choose the positive one, okay? So this is what inverse sine looks like. We've talked about this before. This entire thing, you know, is not a function, right? Because this fails the vertical line test. And so what they've decided to do is to restrict the sine function to just be in between, I'm sorry, the inverse sine function to just be in between negative pi over 2 and pi over 2. And so then that makes it a function. And so we've talked about this before, and what we've talked about it in terms of is the unit circle. And so here is negative pi over 2, here's pi over 2. So this is just a graph way of saying what you already know, which is that the inverse sine of x, we have this in your notes somewhere, has to be in either quadrant 1 or quadrant 4. Okay? That's the same thing just on the graph. Why is it? Oh, because it's the inverse, so you have to flip it around. You have to take the x's and the y's. Oh, okay. No, that would be like the negative. Inverse, yeah, okay. Inverse is when you totally switch the x and the y, okay? We also talked about inverse cosine. Sadly, you can't do the same thing with inverse cosine because then it still wouldn't be a function. So they have restricted inverse cosine to be in between 0 and pi. So again, we've chatted about that before also. In terms of the unit circle, 0 and pi is the quadrant 1 and quadrant 2, and so that's why cosine is restricted to those two things. Okay, we've had those conversations before. I'm sure you recall them fondly. The rest of this is the other inverse trig functions. Inverse tangent is this guy here. Inverse secant. They have chosen this piece and this piece, an inverse cosecant and blah, 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 stuff like that. But like I said, that's kind of, here's like the summary of all that. But we really only mostly care about sine and cosine, okay? So there's no reason to copy all of that down. Okay, what is something that we can do? The little tiny piece that I told you is we can do this without a calculator. Okay, we can do this geometrically. So let's find the tangent of the inverse sine of negative 2 over 3. Okay, are you ready? Not on a calculator, dude. Just said that. We're going to do this geometrically. We're going to do it by drawing triangles. Okay? Yes, ma'am. Are you ready? Okay, so inverse sine, I just blah 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 to you about, has to be in what two quadrants? Right, 1 or 4. So if it's negative, is it going to be in quadrant 1 or in quadrant 4? It's going to be in quadrant 4. So I'm going to draw a triangle in quadrant 4. Okay? And this triangle is going to have an opposite side of negative 2. And it's going to have a hypotenuse of 3. All right? Because sine is opposite over hypotenuse, and so opposite is negative 2, hypotenuse is 3. Okay, based on that triangle, what is this missing side right there going to be? So I can go x squared plus negative 2 squared equals 3 squared. No, because we have to subtract them. So that means x squared plus 4 equals 9. Right? So if I subtract those, x squared equals 5. So that means the missing side of our triangle has to be the square root of 5. You did negative 2 squared plus 3 squared, which is what you would do. It's normally what you do. Okay, so if you have both the legs and you're looking for the hypotenuse, you add. Yeah, and if you have one leg and one hypotenuse, then you subtract. Okay. All right, so now that we have all the sides labeled, we have basically done this part of the problem, and then we just need to figure out what the tangent of this angle is. So what is the tangent of that? No, you got a triangle right here. You don't have to. Opposite over adjacent, so negative 2 over root 5, done. Okay, that's it. Nope, that's not bad. No, as I told you, it's just a little tiny little piece. Well, sure, we can always take this and make your lives miserable using it because it is math class. Like if I made you do this, evaluate y equals sine of the inverse cosine graphically to find the value in radical form. No. Don't want to do that either. Okay, so I think that's all that we've got. Let me come up with some problems for you guys to do. I know that's only one example, so maybe we'll do the first homework one to 10 problems in a math class. It's outrageous. Okay, you guys want to do the first one together to make sure you're on the right track? Okay. Pretty easy, like you guys said when we did that example. Here we go. Ready? Okay, so this time it's cosine. So you do need to know which two quadrants are available for cosine. Cosine is either quadrant 1 or quadrant 2, right? Why is this in quadrant 2? I don't see a negative. It's positive 4/5. The negative 1 just means the inverse. I didn't trick you. I'm not doing any tricks. This is not negative, it's positive. It's not in the second quadrant. He said that. God. Hey, Sky. No to Taylor, okay?
Wait, isn't it in 2?
Okay, joining the conversation that late and you're going to send us down that road again? No, it's not in quadrant 2, it's in quadrant 1 because it's positive, okay? If it's positive, it's in quadrant 1, don't overthink it. All right, hush, hush. So inverse cosine is 4/5. So that means, so 5 is the hypotenuse. 4 is the adjacent. Okay, so we need to find the opposite. No, that's what Mylena did on the last one. Remember, that's not right because we don't have. There you go. So 4 squared plus b squared. Just yell out numbers. I'm in 3rd grade. I don't know how to raise my hand. I just blurt stuff out. Okay, so that means that side is 3. And then you do tangent, which is opposite over adjacent. So in this case, it's 3 over. Okay. It's possible, since like inverse tangent, we didn't talk about what quadrants that's in, but it's positive, so it's just going to be in the first quadrant. So I think it looks like all of these are going to be in the first, most of them are going to be in the first quadrant. I don't honestly remember. Let's go back to the notes and see what quadrant tangent is in, because we didn't specifically talk about that. It looks like tangent is in 1 and 4 also.
So which would we go by? The one outside the parentheses or one inside?
The one inside. Because you're starting inside the parentheses and working your way back out. Tangent is in quadrants 1 and 4, but you don't really care about that because it's positive. If it's positive, it's always going to be in the first quadrant. The only question is whether, if it's negative, is it in the 4th quadrant or the 2nd quadrant? The 3rd quadrant is never used for inverse trig functions. Well, it's used for a lot of other things, but not for this particular piece. The third is, both the x and the y are negative, yeah.